This box and control system is the monitor for the Germination Incubator Box. This is where the seeds get started. The seeds are put in peat pods and then also into styrofoam cups. They're watered and then they're covered in plastic, and they're put inside the incubator box. Inside the box are two LED grow lights. The LED grow lights are not really used right away for lighting, but they are used to heat the box. That's why there is a blanket, a mylar blanket on top, and a t-shirt to kind of keep it insulated and keep the heat in. The display is showing several different temperatures inside the box. The A3 lamp temperature and the A6 input lamp temperature are monitoring the temperature of the grow lights. So if they get past 95 degrees Fahrenheit, it turns on a stir fan. That helps to keep the lamps cool, but it also helps to distribute the heat within the germination box. And the control system will shut off the fan if the temperature inside the box starts to get cold, even with it running, and it's not circulating the heat. So this is the control system, and we see that it's going to tell us the stir fan is running. It has a Arduino Nano with 5 MCP 9700A thermal sensors. It also has a small relay card. I use that to turn the fan on, and a power distribution block. That is the 12 volts for the system to power the Arduino and the fan. This distribution board is for distributing the 5 volt power from the Arduino. The thermal inputs take at most 8 milliamps. The OLED screen doesn't take a whole lot of amps, but there's plenty of 5 volt power for all the sensors and the relay. Kind of take a quick look inside the box. Pull off the t-shirt that holds the mylar blanket down and also keeps the heat in. The mylar blanket is not there to hold the heat in, it's to reflect the light. We open up the box so we can see inside. See, we have seedlings that are in cups that are just starting to sprout. They're covered in plastic to keep the moisture in. There's also a cup in the back to try and keep the humidity up. We have two 20-watt grow lights, and each one of them has a temperature sensor on top. They're kind of hard to see. They're strapped down there, and they're also being monitored, and that controls the fan, and the fan is suspended into the middle of it right here, and it is running right now because it's nice and warm inside. And we can control the heat a little bit by adjusting how much the blanket is covering the vents. If we totally seal it, it can get a little bit warmer than the plants need to be, depending on the ambient temperature inside the room. So this is the incubator for the germination of my starter plants for peppers this year. Ahi Cheripitas, Lemon Drop Ahi. And so at the latest update of the Incubator Box's software, we've had a couple instances. For one, there's one of the thermal sensors, and it's missing now because a cat bit through it, and the cats, if the leaves get down, the cats bite through a couple of them, and the temperatures reach sky high. The other thing that happened is the fan dislocated from its mounting place, And so the lamps got hot, hotter than I'd like. So now what we have is I've added a new circuit on here, voila, with a buzzer and a flashing LED and a little push button for silencing the alarm. And what'll happen if the thermocouples get too hot, it'll start flashing a light and sound the buzzer. And there's a silence button because maybe I don't have to fix the problem right away. I can do it later, but I don't want to hear the buzzer going off. So we'll have to simulate this, because right now it takes a while for the lamps to get hot. This is a thermocouple A3 that was on the lamp, and so what I've done is pulled it off, and what I'm going to do is artificially heat this up to make the alarm go off. And I'm going to use a blowtorch. So here we go. I'm going to torch it, and it takes a while for these readings to take because it's a very slow system. There it says it's 131. You have to keep that on there until it checks all the thermocouples. And there it goes. It set the alarm off. You see the lights flashing and the buzzer's buzzing. Ouch, that's hot, and it's got hot glue on it. And it kind of melted a little bit. Okay. So it'll keep going. And it doesn't service that reset until it gets to the code that's doing it. I didn't put it on the interrupt, because this thing's kind of slowish. Anyway, so we're going to hold it. It would be nicer with an interrupt, but for right now it's okay. There we go. So it reset, and the light is continuing to flash until it goes and checks all the temperatures again. And if it's back within range, it'll reset itself. So we'll hang on tight for a minute, see what it does. Because these sensors have a very long time constant. And there was actually no rush to get the thing to... Oh, it's still hot. That hot glue hadn't cooled it off enough yet. And there it goes. So it has cleared and reset itself. That's a nice, wonderful feature that's been added. And thank you for watching.